I hope my voice is loud and clear to all of you. Hi, good morning, Rishabh. Hi, good morning, Akshay. Nothing was that. Okay. So let us just start in next 2 or 3 minutes. I think the people are still joining in. Right. So let's start in the meantime. Hi, good morning, Ramit. Good morning, Raghu. Good morning, Yash. So did anyone try of using the logistic regression on the decision trees like we were discussing yesterday? Not yet. Okay, anyone else apart from Raghu who got a chance? So is the decision tree is clear to all, right? I hope decision trees is making sense to all of you, like how it is working. Okay. Let's just wait for 2 more minutes. I think 15, 16 people have joined in. So let's just wait if anyone else is joining and then let's get started. Okay. I think we can get started now. Just give me a minute. Just share my screen. Okay. So, like yesterday, what we were doing was we had started off with the topic on the LDA. Okay. So we were discussing, right, like what exactly LDA is and why do we need it. So can anyone tell me what are the two purposes for which we use the LDA for? What are the two use cases of LDA, linear discriminant analysis?
Selection and classification.
Correct, right? So we use it for the variable selection. Second is the classification. So the LDA is also one of the techniques that is used for the classification purpose only, right? And correct, Rishabh. So basically, the main area or main purpose where we will be using this technique is that will be more around when you have all your independent variables which are numerical and the predictions that you have to do, they are categorical in nature, right? So like we saw a small example of that where what we were trying to do was we were trying to see that movers example, right? So which is a owner and which is not an owner of that the mover machine. So now basically how this LDA works is basically LDA defines a score, right, for each of the classifier. So for whatever classifier the value comes to be highest, that is something it predicts as an outcome. Okay. So we also saw this table yesterday where we were trying to identify which technique is more useful, which technique we should be using for what sort of the predictive analytics that you have to do. So if independent variables are categorical to categorical, which technique you use, independent categorical to numeric. So this is just a small table to refer to in case you have to do some predictions. So first of all, what we will do and try to understand over here is, so we will start that how we can use LDA for the feature selection. Okay, when we say feature selection means that how we can use this LDA technique in order to identify the important variables, right? So this is where we use we will understand its first purpose. So how we use the LDA for the feature selection purposes, we use it with the help of a Fisher's ratio. Okay, so I'll be explaining you what exactly Fisher's ratio is. So Fisher's ratio is the technique that is used in order to identify the importance of the variable. Okay, so let us try to understand it. Now, if suppose you have the entire data, okay, and what you have done over here is if you divide that data into two parts. Okay, you divide that data into two parts, responder and non-responder, right? Like when I say responder and non-responder, so let's take that example of churn data only. Okay, so what we are doing over there is that I am saying the people who said yes that they will churn and the people who said no that they will not churn. So you have two data sets. Okay, so what you are doing in that case is in the Fisher's ratio. See, just now, please be clear on one thing, that over here we are not predicting, we are understanding the technique in order to understand that which variable has a higher importance and which variable has a lower importance. Okay, so how we try to understand the technique is we will divide the data into two parts. Okay, we will break the data into two parts, yes and no. So you will have two data sets with you. Like for example, let me come back to this. If you have this iris data set, so what is the predictor variable? Predictor variable is species. I want to predict whether a plant will be setosa or the virginica, or there was one more, versicolor, right? So which type of plant will it be? So what we do in that case is we divide the data into, in this case, we will divide the data into three parts. But let us assume we have just two categories, yes and no. So what we do is we break the data into two parts, yes and no. Then what we do is we calculate the mean of variable for each group. So what we will do in that case is we will start picking up the variables one by one. Say suppose I have a data that looks, say suppose looks like this. I have some age and I have the height and I have to predict the gender, whether the person will be male or female. So I'm saying if age is 21, height is 160, 22. I'm just creating them some hypothetical data, right? Randomly I'm creating this. So we'll just create this ran between 20 to 30. Okay. So I'm creating some random data over here, and height also I will create between 140 to 180. Suppose these are all male and these are all female. Okay, so what we do in this case is we first of all we will segregate this data out. We will keep the data for male differently and female differently, right? So this is how we segregate the data. Then what we do is we pick up the variable one by one. First of all, I will pick the variable age. And for that variable of age, I will find the mean age. What is the mean age that is coming up over here, right? That is average of this age. And then what we do, we find the average of the age of men, and similarly we find the average of age of women, right? This is how we find the average. So in the Fisher's ratio, what we do is first of all we find the average or the mean values of the two variables. Then we also calculate the variance, right? Variance is what is the variation that we have between the data points. Now let me ask you, like now, because you all will be able to answer this by yourself. If suppose now over here, if you can see, I have calculated the two averages. So average age of men is 23.5 and average age of women is 24. If I tell you that the age of a person is 24, will you be in a position to tell that whether that person will be male or will that be a female? Will you be able to tell me that whether I'm talking about a male or female? No, right? Because the mean are very much near to each other. So the average values for these two classifiers on the basis of age is very near to each other. So it will be very much difficult for you. But if I say the average age of man is 30 and average age of women is, say suppose I'm saying let's say 14. Okay, now if I give you that I have a person whose age is 24, or maybe let's say his age is 28, will you be able to predict whether this will be a male or a female? Yes, right? You will be in a position, because now I can see there is a high significant difference between these two mean values, and this value that is lying, you will be easily be able to differentiate that to which area this value is lying. Okay, so what we do in this case of the Fisher's ratio is, in order to identify the features of the variable, I mean to understand the important variables, we calculate the mean and we calculate the variance of each of the group. Now variance is how that data is distributed. Now, then what we do over here is we have a simple formula which we use in order to calculate the power, the discriminating power of the variable, that how strong that variable is or how weak that variable is. So what we do in that case is, this is the Fisher's ratio that we use. Now this is the formula that we use in order to calculate the importance of that variable. So we say Fisher's ratio is equals to m1 minus m2 raised to the power 2 divided by v1 plus v2. Okay. Now m1 and m2 is the mean value, right? Mean value of yes and mean value of no. So you calculate the Fisher's ratio for each variable. Okay, you will be calculating the Fisher's ratio for each variable, and that is how you will be calculating the significance of the variable and divided by the v1 plus v2. Now, if suppose the difference between the mean value is high, okay, if the difference between the mean values of group 1 and group 2 is high, so will the Fisher's ratio increase or will it decrease? Increase, right? So it will increase. And if suppose the variance is high, if the variance in the data is very, very high, so in that case, the Fisher's ratio will increase or decrease? It will decrease, right? The Fisher's ratio will decrease in that case if these values are high. So what was variance? Variance was basically, if you see over here, like from this chart, so variance is how much data, how do you have that data scattered, right? So variance means the data is largely scattered, right? So you can have a person, if the mean age is 30, you can have a person of age 40 also, and a person with an age of 18 or 17 also. So if there will be huge variation in both the groups, so again it will become very difficult for you to predict, right? Like what is, whether that person is a male or a female, right? Like if I come back to the same example over here, and if I say that we have the age of the male lying between the range of 50 to 17, and same is the case for female also, the age is lying between the age group of 15 to 17, if the variation will be very high in both the groups, again your predicting power will become lower, right? Because you know that for a very high age we have male and female, for very young age also you have a male and female. So again, that way your predicting power will go down. So that is why, keeping all those things into the mind, this Fisher's ratio has been created, right? So you can see the formula for that is m1 minus m2 to the power 2 divided by v1 plus v2. So greater the Fisher's ratio, right? So Fisher's ratio, the greater is the greater will be the importance of that variable. Higher the Fisher's ratio you will get, higher will be its the importance over there in that model. Now Fisher's ratio will always be positive, right? Because m1 minus m2 raised to the power 2, since we are taking a square and variance is any which way the square only. So that is why the Fisher's ratio is something that will always come as positive. Okay. So now what we will do over here is, let us try to see that thing with a small, this diagram also, right? If you see, say suppose this is the normalization curve for the two data sets where we have two respondents, 0 and 1, and this is another data set, and this is the third data set. So among these two data sets, where do you think the Fisher's ratio will be the highest? First, second, or third? Okay, so Yash says 1. So Rishabh says 3. Okay, so we have got two answers, 1 and 3. So anyone with 2 also, so that we have all the options in the answer. Mozam, you also say 3. right? So why 3, Pooja? So why shall we using the option as 3 in this case? See, difference, right? So if you see basically, these are the normalized curves. So in the normal curve, in the center, you have the mean values, right? So mean, median, mode lies over here. You can see there is a very less significance. And over here, I mean, there is less difference. Over there, this difference has increased. And also another thing to notice over here is the variation. Do you see variance? How broad this curve is? Broader the curve means higher the standard deviation, or you can call it as variance. And in this case, what is happening now is the variance is very low. And further in this, the variance has further decreased. And the best thing is the mean values are very apart from each other. There is no overlapping that is happening at all. So it is very easy for me to tell from this chart to which group a particular variable or a very particular respondent will lie, whether he will lie in this group or he will lie in this group. It is easier for me to predict that output, right? So that is why third is my option, which I shall be using over here in order to tell like which scenario will have higher Fisher's ratio. Okay. So if you see over here, so again, let's try to see a small example. If you see in this first diagram, the mean value is 100 and 103, and standard deviation is 2 and 2. Okay. So now if you try to take a look at this chart over here, now can you try to identify which has a better Fisher ratio? Just try to use this and try to put this into the formula and try to find the answer. So just put it in the formula over here. And basically, if you see in these two charts, both have the same mean between the two. Same, it's not possible, right? So what is variance? Variance is square of the standard deviation, right? Square of the standard deviation is variance. So if you will try to find this over here, right? M1 minus M2. So if you just put it in the formula 100 minus 103, that is 3. 3 raised to the power 2, 9. 9 divided by this V1 plus V2, right? 9 divided by 4 plus 4, 9 divided by 8. And over here, this is 9 divided by 2, right? So Fisher's ratio will be higher in this second case. Correct? Because the formula for Fisher's ratio is what? M1 minus M2 raised to the power 2, M1 minus M2 square divided by V1 plus V2. So if you find the difference of the mean, that will be 3, 3 raised to the power 2, that is 9, 9 divided by 8, and the another one is 9 divided by 2. So the Fisher's ratio is something that will be higher for this second series. Correct? So I can see from here that, so the lesser is the sum, or the lesser is the sum of variance. You can see the sum is less over here. More clear is the distinction. You can easily figure out that to which group will it belong, right? If you see over here, the variance is very high and there is a lot of overlapping that is happening in this data. But over here, the overlapping is very low because the variance is less between the 2 points. That is why this chart will have a clear distinction, and it will be a better, if you have this chart, your predictions will be better in this scenario. So that is the basis of the feature selection that we have. Okay, so now let me do one thing. Let me just give you a small quick question over here, right? So let us do that. fishes ratio. Okay, so let me do one thing. Just all of you, please log on to your Google Drive link, the link that I shared with you. Okay, please log on to that. Just give me 1 second. I'm just telling you all to download one of the file. So, this will be a good practice. Let's see if how many of you are able to do it. You will find on the LMS under the R datasets, you will find a file by the name of wine quality. This is the file LDA08. Please download this file. Okay, class. I'll just be back in a minute, right? So have you all downloaded this file? Right. So what you all have to do in this is basically once you download this file over here, this is the file that you have. Okay. So this is the data about regarding the wine quality. Okay. So if you will just go through this data over here, so it is telling you that whether the what is the quality of the wine? Is it of a low quality or the wine is of high quality? Okay, so the quality is being defined on the basis of certain variables, like what is the acidity, what is the volatile acidity, citric acid, residual sugar, chlorides, etc., etc. Right? So what I want you all to do is you have to determine which is the most significant variable in terms of identifying that, on which variable is the most significant in terms of identifying whether the wine is of high quality or is it of low quality. Okay, so you all have to do that feature selection on this, the variable selection. You can use R, right? So because if you will use R, you will be able to do that more quickly. So you do not have to use, you don't have to do it in the Excel only. So you can use R also in order to find that out. I hope you all are able to download the file. Hello, class. I hope you all can hear me. Okay. So just wanted to check, right? So file is downloaded by everyone, right? Okay. So now what you all have to do is you have to use this data to identify which variable has the highest significance, right? In order to determine whether the wine is of low quality or it is of high quality. If you want to use Excel, you can use Excel. If you want to use R, you can use R as well, right? So we know that how to do that, right? For that, what we have to do is we have to use the Fisher's ratio. And the Fisher's ratio, what we do is we say M1 minus M2 raised to the power 2 divided by V1 plus V2. So I will, advise you that you should try, you should all be doing this in the R only because over there it will be much simpler and easy to do it. I mean, you will have to use both R and Excel. Simply in the R, you will not be able to do it. Because technically, if you see, you have to calculate, first of all, you have to break the data into two parts, low and high. And then for each variable, you have to calculate the average and variance. These are the two things that you will be requiring. Okay, so let's all do this thing together over here. So let's just close this previous stuff. So first of all, I will make my folder where this file is placed as my working directory. Okay, and we will create the data, and data will be read.csv, and the file name is lda08.csv. Okay, so I have uploaded this data where we have 12 observations and 4998 records 4898 records. Okay, please do this. First of all, upload the data. Done. So now what I will do over here is, if you want to find the mean and variance, right? So you can use your functions also, different functions also. We have like summary functions and all that. But what you can do is, if you remember, there was one package that we discussed, that was psych package, right? So there was a package, psych package. I will put that package into my library, psych. Okay. Now this package has a very exciting function inside it that is describe. Okay, if I say describe the name of my data set, let me just call it as wine. So that will be a better representation. Wine, right? So let us call it as wine. Let's remove data. RM. Okay, so I'm just removing that. So let's use describe the wine data on this. So when you use the describe function, see what happens over there is, it will basically give you a lot of information that for each variable, it is giving you, like for acidity variable, what is the count, what is the mean, what is the standard deviation, what is the median, what is the trimmed value, mean average deviation, minimum value, maximum value, right? It will give you a lot of information, max, range, and skew and kurtosis. Okay, but what are the information that we are interested in? If you see, we are only interested in the mean value and the standard deviation, right? If I'm able to get that information, my job will become very, very easy, right? I will be able to calculate my Fisher's ratio, right? I hope you all are with me. So these are two things that I need to do. So what I'll now do is, and that too, right now when I've used this describe function, it is giving me the mean, standard deviation, median for entire data, but I have to find this information separately for low and high, right? I will have to find this information separately for low and high data. So what I will do now is, I will say over here, we will come up and we will see, I just want to take the mean and standard deviation of low and high of L and H. So first of all, what I will do is, we will calculate it for low. Let's create a variable L, and I will say I want to describe, my data set name is wine, and in the wine I only want to use that data where which, so I will use the which function, which the wine underscore quality, right? So wine quality is equals to L, right? First of all, I will capture the data for where the wine quality is low, right? And if you see, when you executed this describe function, it gave you a lot of variables, but I'm only interested in the variables that is the standard deviation and the mean, right? That is the third and fourth column. Okay, these are the columns that I'm interested in. So I am saying, when I'm describing, I have specified over here the data set that has to be used is, that has to be the wine data, okay, in which the wine quality should be equal to low. Okay, this is something that we have defined. I only want to pick up the data for one of the categories where the quality is low, and definitely I do not want to describe or get the information like what is the mean, median, mode for quality variable, right? Because we cannot calculate that thing on this. I cannot calculate what is the mean or median for quality or the L or the H over here. So what I will do over here is I will specify I want to pick these variable, and from this data set I want to remove the column 12, and then that describe function should be calculated. Okay. Oh, I hope this is clear to all. And when the output will come up, from that output, I want to keep all the rows, but the columns that I want to keep, they are only 3 and 4. So I'm defining, first of all, I have defined the filter on my data set, and the output that will come, right? Like if I say describe vine. So if I will say describe vine, I want to see all the rows, but column only 1. So when I say column 1, it will only give me the count, right? Oh, sorry, vars. It will give me only the vars, the variable number over here, right? 1, 2, 3, 4, 5, 6 up to 12. And if I define, I want to have the column of 1 and 2, so it will give you var and the n also. Okay. So this is the same thing that I've done over here. Oops. What is? First thing wrong, undefined selected columns. Hello, your class, can you hear me? No, I think because it's raining over here in Delhi, so there's a lot of power problem that is happening today. Okay, So what I was trying to do was I was explaining this describe function. So in the describe function, what I have done now is I have simply said that when you say describe and tell that data set wine, so it gives you the complete statistics, right? So it gives you all this information over here if you will see. It gives you all this information, right? Where mean, standard deviation for each variable. So what I'm doing now is, because I want to have that statistical summary for data set where the wine quality is L and where wine quality is H. And I'm only interested in two of the things, that is mean and standard deviation. Okay, right? So if you see, there are two filters that I'm applying. First filter is on the data set, that I only want to use the data where wine quality is L, and then from all the statistics that are generated, I only want to keep mean and standard deviation. These are two things that I want to keep. Okay, so this is the same thing that I have defined in this function. So I'm saying describe the data set which I want to use. I want to use only that data where the wine quality is L, and where I'm saying C minus 12 means, because by default what happen is, your when you use the describe function, okay, okay, so what happens is, when you use this describe function, so describe function automatically picks up all the variables, this also up till the last variable. Now this is the 12th variable that you have, quality, but I do not want to calculate the mean, median and everything on the quality variable, correct? So that is why I have written minus 12. Minus 12 means remove this column, except this column, use all the other ones. Okay, so this is something for rows, and this is for the column. And then outside that describe function, I have defined that I only want to keep the third and fourth item. Third item is mean, and the fourth item is standard deviation. So this is what we have written as the formula. Okay, yes, you can do that. So what it is, just that you will have to add an additional step in that case. First you will make your one data set, that filter data equal to L, and on top of that you will apply your describe function. So you can do it any which ways. If you want to do it this way, so you can straight away use the which function and you can apply that filter right over here itself. Okay, so what will we miss? So, okay, let me just check this out. Describe wine. So okay, inside this I'm saying which. Okay, so this is, if you will now check the L, if I say view L, so I've got the mean and standard deviation over here for this variable, for where the data set is L. And same way I will create H also. In the H, everything will remain the same, only one thing will change, and that is wine quality equal to H. If I now create this and I will see this view H, so I can see all the information has been generated for this variable also. Okay. So all of you please try this out. Okay, now what you can do from here is the data set that is created. You can simply copy this stuff. Okay, you can copy this information. And what you can do is you can put that information in your Excel. Okay, you can put it over here. This is the data set 1. And same way you can come back. This we picked off H. Now you can pick it for L. Okay, this is for the data set high, and this is for the data set low. Now, first one is mean. This is the mean. This is the standard deviation, and same is the case over here. This is the mean, and this is the standard deviation, right? So what you can do now is, can you all calculate the variance? Variance and variance. So variance will be what? Equal to this raised to the power 2. So you get the variance over here. And same is the thing you will apply over here. So you have got the variance over here also. Now you have the mean also and the variance also. The only thing that you have to now calculate is that is the Fisher's ratio. And what is the Fisher's ratio? Fisher's ratio is m1 minus m2 raised to the power 2. So I will say this number minus this number raised to the power 2 divided by V1 plus V2. Okay, if I drag it down, so I will get the Fisher's ratio over here. And what we can do now is I'll just copy this over here. And these are the variable names. This is variable and this is Fisher's ratio. And what I can do over here now is I will simply select this data from here and I will custom sort on the basis of Fisher's ratio from largest to smallest and click OK. So I can see the highest importance is coming for the variable alcohol, then for density and for chlorides. And as I go down, so these are the variables that are not that much significant in terms of predicting whether the wine is of low quality or it is of high quality, right? So we have calculated the standard deviation and the mean, we calculate the variance, and then we have calculated the difference between for each of the variables, and we have calculated the Fisher's ratio for all of them. If you want, you can do this.
So the last part we did via Excel. Is there a way we can still do with the R or Python something? Do they have any inbuilt function for the Fisher ratio?
You do not have any inbuilt function, but you can create that calculated column, right? So what you can do over here is, like, if in this case, these were the two data sets that we created, H and L. So what you can do is, in the L data set, what you can do is you can do the C bind, column binding. Okay, so you will get the entire data set in one single data set. So let me say, let's create new data set. So you can say C bind L and H. Okay, so if you will now take a look at this new, so you are getting all that data over here only. Okay, mean and standard deviation. So what you can do is you can calculate the variance 1 and variance 2, just so you can square the numbers over here. So everything that I've done in the Excel, that can be done over here automatically over here, right? So then you will have to calculate your, in this data set, what we can do is you can say that over here in this new data set, you can create a new variable that is by the name of, basically you'll have to also rename the variable names because the names are coming same. So you'll have to rename the field as this as mean and st. You will have to call it as mean and the so Satyaj, you will have to install the package first. Install.package is psych. Okay. So you'll have to, if you do not find this, so you will have to run this command install.packages psych. Okay, then you will be able to run it. So right, Raghav. So will you be able to take it up from here? So I've given you the complete the idea over here how you can do it. So as such, you will not find direct function of Fisher's ratio, but you can calculate that by creating a new column, a calculate field over there.
Sure.
So you can use the function of that in the tplat package. We did that, right? The mutate function, right? Mutate and transmute functions we used in order to add the calculated fields. You can use that, or you can do a simple calculation also. Others, are you all able to get it? Like what we have done, how we have calculated the Fisher's ratio? Anyone still having any doubts over here?
Amit, just one question. We have nowadays, like, I heard we have a lot of, those tools like, Alteryx and Nime, which are doing like, all this processing without much of the coding. Like you just need to drag and drop. It's more like, a drag and drop utility. But again, you need to also have the basic understanding of, how the statistical stuff is working. Is there any use of those tools which is right now being used across industry?
See, it is very less those tools are being used. Like you will not find those tools being used at a very large scale, right? So those tools are like, those tools still have a lot of limitations within them. So they're not the full-fledged tools that are available. So like in the R also you will find some packages like, you will find the package of Rattle that you can use. Similarly, there is Julia that you can use, but they are not like developer friendly. Okay, they are like more like if you have to do a simple statistics, or even if you want to do it advanced, but still you need to have a deep understanding about all the functions. Only then you will be able to use it. Because I have not seen many people using that, because in the industries also I see people working on this R Studio or on the Jupyter in the Python. So those are the platforms that I use mostly like these days, because there are a lot of the AI based tools that have come into the market, right? Like there is the what IBM Watson also, that is there is also Microsoft Azure Studio you will find. So ML Studio basically, that is also completely drag and drop based, but I have not seen much the use of them tools up to now. Maybe in the next couple of years they will become a hit, because a lot of advancement will happen on those tools.
Okay.
Akshay, so could you please show how to copy the data? Okay, copy the data, you just simply open that up data set over here. Okay, you say H, when you will view it, you can simply copy it from here. So just copy the data from here like this, and you can paste it over there in the Excel. Control C and Control V. Okay, so I gave a naming that this is the mean, this is the standard deviation, this was my data set of high. Okay, similarly you can copy and paste it for low as well. And standard deviation was given to me, so I just squared it up in order to get the variance. I just squared this number. Okay. It's not getting copied, strange. So are you copying it from the console window or you are copying it from this over here, this data view? Can you share your screen?
Yes, sir.
Just give me a moment. Okay, just copy this, press Control C. Control V over here. It's not doing. Oh, just go back to that table, right? Go back over there. Go back to the R. Now press Control C over here. Just press Control C. You are just copying that one single cell. Press Control C.
It's still not coming.
No, copying is the stuff that you're copying, that is not getting copied properly. Just go back to that R once. Okay. Now do one thing, just click outside. Just click somewhere. Click somewhere over here. Okay. Now select from that this portion of fixed acidity. Start selecting from that fixed acidity. And now press Control C, press Control C. Okay, now go back to the Excel. Just add a new sheet. Add a new sheet over here. Okay, press Control V over here now. Are you using some Excel online?
No, this is a normal one.
Because I am doing and the normal copy page, it is working over here. So not sure like what could be the problem in this case. Do you see paste option? Just come over here, and you see this first option over here above this. Yes.
This one?
No, it's not pasting it. No worries. I mean, so how you can, because I just did the same thing. Can you make me the presenter once?
Yeah, sure.
Sure, I'll just let me share the code. Because I'm just doing the same stuff, I'm just copying it from here and like this. Once I copy this, I'm simply Control C and I'm just pasting it. This is working for me. Okay.
Fine,
So,
I'll check.
others, are you all able to achieve this? Just check it once. Some trouble, I think, with the copying, not getting the stuff is not getting copied properly. It is just copying the first cell. In your case, it is just copying this stuff like this only. This is getting copied somewhere, and that is getting pasted. Okay, so shall we move ahead? right? Abhi, you are able to copy it. Yeah, I mean, let me just see what could be the wrong thing. It's working fine. Yeah. Okay, so we have seen how we can calculate the Fisher's ratio, and we have seen that uh, how we can use that variable in order to identify which variable are significant and which are not. Now, what we will be doing is we will be using this, understanding this LDA, that how we can use this for the classification purpose. Okay. So in the classification purpose, also see what happens in basically in this model is a similar kind of an object, a similar kind of the thing is done, where what happen is what the model does is it breaks the data into two parts, right? You will have the data broken up into yes and no. Okay. And then what it does is it calculates the distance of the new object from the mean of the different populations, right? So what will happen is it will calculate the mean of this data point, and it will calculate the mean of this point, right? The same thing, right? When I was telling you that we break the data on the basis of the yes and no. Now what it has, so this is just hypothetically that I'm telling you that how the things will work. So the new object that will come into the picture, it will see, is it uh, to which mean it is more near? Is it nearer to the mean of this data set, or it is near to the mean of this data set? So whichever mean it will be closer to, it will be assigned to that group, right? It is like, the output over here also will come in the form of probability only, right? So what is the probability that it belongs to group this, or what is the probability it belongs to group this, right? This is how the output will come up for the LDA also. So what we do in this case is, if I just try to explain you the step by step, so we calculate the distance of the new object from the each center, and we use the function of distance over here. So let me do one thing. Let's rather do this thing practically. That will be better. Okay. So on that drive only, right? So I have over there you will find a data of movers data. Okay, there is a file that you will find movers data over there. So please download that file, copy of movers data. It's a CSV file that you will find. And this is the same data that which person is owning a mower machine and which one is not. So we will use that data itself over here. So please download this data file once. Okay. So this is the data that you will find over there. So in this data, you have income and the lot size. And we have to predict whether a person is a owner or not. You have to predict yes or no. Right. So we already have this data with us. So please download it. I hope you are able to download that file. Okay. So the file name is Swati, that is the movers data, copy of movers data. That is the file name that you will find over there. Done. Okay, so let us load this data, right? See, up till now, how we have loaded the data is, so what we used to do is, so the file is CSV file. So how we used to upload the data was, let me call this data set as owner, and we used to say read.csv, and then we used to give the file path, right, where that file is, or we used to give the file name. There is one more way that I will now like to tell you over here how you can select the file. See, if you do not want to go into the hassles of making a folder as a working directory or copying and pasting the path of that file from that location, you can use one function that is called as file.choose. Okay, if you will use this function, see what will now happen is, oops. It's stuck. Okay. So when you run this command, what will happen with you is it will right away give you the the option to navigate where you can select your file, right? So I will like to choose my file over here, that is this class demo. Okay. So if I open it up, oops, this is not the file. Okay. So the data is loaded. So let us view this file now. So we have loaded the data of owners, and this is how the data looks like to me. So income, lot size, and owner and known owner. Can you visualize this chart? Can you all create this chart using the ggplot? The same chart that I had shown you yesterday in the PDF file. Can you create that chart over here? So if you want to visualize this thing, how will you do that? So if you want to create a plot, so we will have to put like ggplot in the library. Okay, so we will create a plot over here and we will say ggplot aesthetics. On the x-axis we will keep so what all variables do we have? So it's better to copy this variable name. And y equal to income plus which chart will I create? Geom point, right? So I can visualize this chart. Okay, so if you just let this out, so this is how the chart looks like, right? And what you can do is on the geom point, you can define aesthetics again, and you can say that shape equal to vector of the variable that was owner's true. Okay, so this is how the chart looks like. So triangles are the owners and circles are the known owners, right? So this is how you can visualize it. You want to put it on the color also, you can do that also if you want to give it a colored feel. So it will become exactly the same way, the way we were using over here. Okay, so I'll do that. So I'll simply create a ggplot only. So where I've defined the dataset name, x and y axis, and the chart type. The geom point aesthetics. On the aesthetics, we have defined this the shape. Okay, see, you know what now happens in the LDA is a very simplified approach, right? It is not at all technical and it is not a very, something very sophisticated model to implement, because, we are mostly dealing with the numerical data and we are trying to predict a classification outcome. And it is simply, I can call it as a more, modified form of a linear regression only. Somewhere it is like a linear regression only, because in the background, it also creates a linear equation. So what we'll now do over here is, I'll just show you how this LDA algorithm works. Okay, applying LDA. So we will apply this LDA model technique over here. So in the LDA technique, what we do is we use something that is called as cross-validation technique. Okay, we use cross-validation technique. Now, what is cross-validation? So let me explain you. See, in the cross validation technique, what happen is, suppose your data set has 30 rows. Okay. So in this technique, what will this LDA technique will do is, it will pick up for the first row, it will, to predict the data for the first row, it will use the rest of the 29 rows. Okay, it will use rest of the 29 rows, and based using that data, it will predict what will be the outcome of the first row. And then it will go to the second row, and for that second row, it will use the remaining of the 29 rows, that is the first row and the row starting from third to 30. So leaving that second row, it will use all of the other rows in order to predict what will be the outcome for the second row, right? So this is basically, this is called as, this is something, the approach that we will be using over here, that is also called as jackknifed approach. Okay, we use the name as jackknifed approach. So jackknifed approach means, in this what we do is, we leave out one observation, and then uh, based upon leaving on that observation, we try to predict the outcome for the rest. Using the rest of the observations, we predict the outcome for that. Okay, so this is called as jackknifed approach. So we are using rest of the data to predict the outcome for each of the rows over there. Getting the point? Okay, so what we do in this case is, what we will do is, we will need a package for this, and that package is mass. Okay, because mass is the package that has the LDA function built in it, right? So like in the decision trees, we were using rpart, that was available in the rpart library. Similarly, we will, for using the LDA algorithm or the LDA technique, you will have to install package mass. So please install that. Okay, once you install this package, you have to put this into the library. The package name is mass. Okay, so please all of you do this. I'll just share this code also on the chat. And there is also another advanced version of LDA, right? Like we have LDA, there is also one more technique that we have, that is called as PCA. Okay, PCA is something that stands for principal component analysis. Principal component analysis. Right now, this is like a more advanced technique over the LDA, which is again used for the purpose of similar classification problems, and it is also used for the purpose of identifying the significant variables. Okay, so this is something that you will be learning in your Python training, that when it will start, right? PCA technique. So this is how the things have been designed. So over here you are getting an overview on the LDA, and the PCA is the technique that you will be discovering and learning in your the Python training. And this PCA is also again kind of a lot of stuff, that a lot of questions are asked around in the interviews from the PCA side. Okay, so I hope you have all this package now. So what I'll do now is, let us come over here now and let us create our model. So I will say model. Okay, In this model, I will be using my function that is LDA. Okay, that is a part of the mass package. See, everything is remain right same. So I will say owners. Owners, the name of my variable is owners true, right? So this is my predictor variable, and I'm saying this predictor variable is dependent on all the rest of the data. And what is the data set that I'm using? So I'm using right now, because my data set is very small. Okay, since the data set is very small, so I will use the complete data set itself. Data is equal to owner. Okay. Now, since we are using a jackknifed approach, right? So we are using a jackknifed approach. So what I will do is, in which we say cross validation is equals to true. So you will have to specify CV equals to true in order to, basically tell that we are now, the model that we are creating right now, this is a jackknifed approach, where what will happen is you will be predicting each row by using rest of the rows over here. Okay, and you can also add a function over here that is na.omit if you want. Na.omit is if in case in your data there are some na values that are available. So na.actions equal to na.omit. Okay, so you can use this as a function if you feel you have some missing values in your data. So in our case, we do not have any missing values inside this, so we can go ahead with this. Even if I remove this function, still it will be fine. Okay. So I mean CV equals to true means this is something where we are defining that we are using the approach of jackknife approach. When you say cross validation, in the cross validation technique, what happen is basically if you have 30 rows of data, okay, so it will pick up the first row. uh, for the prediction of the first row, it will use the rest of the 39 rows of the data. Okay, and then when it will pick up the second row, for the second row, it will use again the rest of the 29 rows for prediction that whether the output will be yes or no, right? Whether a person is owner or not an owner, right? So that is called as cross validation. CV means cross validation. Same data set. What is happening is there is a cross validation that is happening on the data set, whether the output is yes or the output. Okay. Right. So all of you please create the model now. So you will see the model will be created. And then you can see the results. So now this is how the output has been, achieved over here. Okay. So this is the variable class. Okay, class means the thing that we were trying to predict, yes and no, right? That is called as classifier, because in the formula we have defined over there owners true is my predictor variable, the target variable, and rest of my are the predictor variable. So it is able to pick up that okay, this is my classifier. So we have two levels, n and y. Okay. Then what happens over here is, what this model does is it calculates the posterior probability, right? So if you see, we have 24 rows, and you can see that 24 times the probability is coming. So this probability is that for the first row, right? For the first row, what is the probability of having no and what is the probability of having yes? Okay, this is the probability score that has been calculated. Now this score has been calculated on the basis of the rest of the data that you have with you. Okay, so it is saying that for the first record, the probability for having not owning that, for the probability for not owning that mowing machine, the probability of no is 0.84 and probability of yes is 0.15. So it is giving you the output in the form of probability over here for each of the rows that you had, right? So it is not giving that exact one single value, it is giving you the score for no and yes. And if you remember, like, yesterday when we were discussing, so what happens in the LDA is the score is defined, and whichever class the score is higher, that is given as the output. That is defined as the output, that okay, for this particular row the outcome will be no, for the another row the output will be again no, right? Because I can see over here also the probability of n is higher, and over here in the third case the probability of yes is higher. For the third row the output will come as yes. Okay, so this is how this model of LDA is created. So first of all, please all of you create it and just try to see the results. Okay, are you all able to create it? Okay. Okay. So I think let's take a short break over here, right? And after the break, we will continue on this. So it's 10:38. So let's just take 15 minutes of a break and then let's start from here. Hi all, I hope you all are back from the break. So let us now start with this, right? So now, the model creation we have done. So now, can you all just, I will explain you this result, right? I will just explain you what exactly the output you have got over here. Just give me 2 minutes. In the meantime, with the model that we have created, can you tell me the prediction, how the accuracy is coming and how are the predicted results that this model is giving you? Please, all of you, please try this out and do the predictions. Because there is one more technique that I will be just showing you in just a little while. And then I will be just explaining you this result. But in the meantime, just do the predictions. So the model is here. So in this data set, because the number of rows were very less, so I have not created test and train data set. Okay. Anyone who has done it? It's a simple predict function that we all have to use. Okay, so let's do that. So this is the model that we have created, right? So if you click over here, model dollar class. Now this is giving you the predicted outcomes that are coming, right? What that model is predicting the results. So what I can do now is I can use my table function. I will say from my owners data set, I would like to pick up the value of owners true, comma, model dollar class. So this is what the output is coming, right? So this is a confusion matrix that has been created. Here I can see 5 of my outcomes are incorrectly predicted, right? So total values are 24. So if I say 5 divided by 24, so I get an error rate of 20.83, right? So this is the error rate. So almost like I can say I have accuracy that I'm getting is of 80%. Okay, this is the accuracy that I'm getting when I'm using a jackknifed approach, right? Jackknifed approach means where all of the rows are used for the prediction of the first row. Now, there is another way of creating the model. Okay, so there is one more way of creating this LDA technique, assessing the LDA technique. Okay, the other way. Now, in this way, what we will do is we will not use the cross validation technique. We will keep it as false. Now, when you keep that as false, in that case, the entire data set is used in order to do the predictions. Okay, complete data set will be used. So for all the observations. So this time we will be using the complete data. So nothing much will change, right? Nothing much will change. It is just that one of the lines, that is CV equals to true, we will not be using that. By default, it is false. So what I will do now is, I will first of all create a model. So I'll call it as model 2. I will be using LDA approach, right? Now I will simply define that this is my target variable, owners underscore true, that is the name of the variable, is dependent on all the variables. Data that I'm using is data is equals to owner data, right? That's it. So I will not apply the CV equals to true cross validation technique. My model is created. Let us now predict the results. So if you now predict the results, predictions, we will be able to do it. Let us simply say model $2. Predict model 2. Okay, so this is the yes and no that is coming. So let us create a confusion matrix and let us see if the accuracy has improved or it has degraded. So the data that I'm using over here is, that is owner dollar Okay, so now you see my accuracy is now, this classification is coming 3 by 24. So 12.5, right? So we are getting an accuracy of almost like 88%. So this is another technique that I have used over here. Now what I will do is, just stay with me, right? I'll just for 5 minutes, just follow the thing that I'm trying to explain. And you can all write your code as well. Okay. Now what I've done is, I have created the model second time. Now in this case, I have not used cross validation technique. So let us see what is the summary that you are getting, and let me try to explain you the summary of this model. Okay, so if you click on the summary, so summary of the model 2, right? So you will get some lot of informations over here. Okay, so it is giving you prior and all. So let's just simply run model 2. Okay, so this is the information that is being generated by this model. So let me now just try to explain you let's try to understand the model, what exactly the information is being generated by this model over here. Okay, so all the information is not important. There are few important things that this model generates. Now this model will generate some of the things like, this is model 2 dollar prior. Okay, so when you create a LDA model, so what this model does is it calculates the prior probability, right? Before creating the model, what was the probability of no and what was the probability of yes? So in your data set, the data set that we have used, in this data set, what is happening is, if I'll just open that up, you will see we have total of 24 points. And if you calculate no, there are 12 no and 12 yes. Okay. So what is the probability of yes and no before the model is created? That is called as prior, right? This is the information that is generated by this LDA model technique. So which is coming as 0.5 and 0.5. So model prior 5, this is something that is called as the priority before the model is created, right? It gives prior priority. It gives, I will say, prior probability of the class. Okay, this is something that is generated by this model. Then what you will see is the another information that this model generate is that is the count. Okay, model to dollar counts. Okay. So if you will see, it basically gives the count of each of the class over here. Okay, so basically what is the count that you have? Okay, then the another thing that this model will give you is that is the model to dollar, you have the value as means. Okay, so you can find what is the average of income, right? Remember Fisher's ratio that we did. So you can see what is the average variable, what is the average value of mean for all the variables that you have. For no, what is the average income? For yes, what is the average income? For no, what is the average lot size? And for yes, what is the average lot size? Right, so you can see the mean value. So because if you remember when we were discussing LDA approach, we discussed that how this LDA approach works is it will put that data point into that particular group from where the mean value is closest, right? If you will see the mean values, if the mean value is coming closer to this, it will predict the output as yes. If the mean value is closer to this, it will predict the output as no. Okay, so this is the information that gets generated when you actually create the model using the LDA approach. Then after that, what you do is the another information that is generated within the LDA model is that is model dollar your this scaling. Okay, so model dollars this the scaling is something, you know, this is not generating null, sorry, not model. Okay, right, so this is the model 2. So you get this scaling. So these are the linear coefficients. Okay, if you remember what I told you was that when you create a linear discriminant analysis model, in the background there is a linear equation that gets generated. And now what is happening over here is it is giving you the coefficient of each of the variable, right? So what is the coefficient of income and what is the coefficient of lot size? So it gives you the coefficient values the same way that we used to receive in the linear regression. So this is the same stuff that has been generated over here. Okay. Then the next thing that we use over here is that is model to dollar that is SVD. Okay. So what is SVD now? So SVD is something that is called as the ratio of in between and within group standard deviation of the variables. Okay, what is this? Let me just explain you this. This is the ratio of between and within group, okay, within group standard deviation on the LTA. Okay, so please just, you know, so these are the important stuff that gets generated, right? So first of all, just please all of you take a note of these things now. Okay, and then we will discuss it further after this. Just please all of you take a note of these things. Sure, I'll do that. From model class, you're asking. And there was one last portion also, that is this. The okay, so are you all able to? So let me just try to, just now. If I'm hoping that you all have made the notes over here. So what we did was, second time we created the model in which we didn't use the cross validation technique. And when the model was created, we checked the accuracy and we saw that the accuracy increased significantly, right? Previously it was 80%, and without cross validation technique, the accuracy was coming as 88%. Now we were trying to understand the model, right? Basically what the model is doing. So what this model does is it identifies the prior probabilities, right? What was the probability of yes and no before the model gets created. Then what happens is it gives you the count and the mean values. So what is the mean of the variable? It gives you the linear coefficient of the variables, of the predictor variables. And then it also gives you the ratio of between and within group of the standard deviation on the LDA variables. Okay, so what is this basically? If you just try to understand, ratio of between and within group standard deviation, right? So what happen is we have two of the variables right now. One variable is income size and another is lot size, right? So we have two variables with us over here. So there will be one variance that will be lying inside this group, okay? And then there will be a variance of the another variable that we will be having, okay? So it calculates the variance of these two groups and what is the variance between the two groups, right? This is how the variance is calculated. and it takes a ratio of that. So it will add up the variance of within group and divided by the variance of between the group. So it is the ratio of those two variance. Okay, so that is, so higher the ratio, better the probability, right? So basically better will be the chances that your accuracy will increase. So these are the important stuff, that this LDA model generates for you. So based on which we predict whether the outcome will be yes or no. And so technically it is more like a linear regression only, where the linear coefficients are being used in order to predict whether the output will be yes or no. So for linear coefficients are for all the variables. Okay. So, yep. So this is what we have largely on the LDA, right? Now, LDA technique, if you would like to try it out, right, what you can do is you can use the iris data set to create your the LDA models, right? What you can do is you also have another data set that I just shared with you, that is the wine data. Okay, you can use the wine data also in order to predict whether the wine quality will be of a low quality or it will be of a high quality, right? So you can use that data set. So there are multiple data sets that we have on which the LDA technique can be tried, right? But if I talk in terms of practicality, okay, like to be very honest, like in the practicality scenario, this LDA model is something that is very rarely used, right? LDA is used very rare. The reason for that is because there are very few situations where you will be getting all the predictor variables as numeric and the target variable as categorical. You always get a mix of the data. Like in 99% of the projects, you will always get mixed kind of a data where you will have a numeric variable plus the categorical variables. And that is where the LDA will not work. So you will only have to go with the option of either the logistic regression or the decision trees, right? So LDA is something that we use largely for the variable selection only, right? The 80% of the areas where you will see the LDA is being used, it will be used for the feature selection to understand which variables are more important and which are less important, right? So that is the widely used case that you have for LDA approach that we have. Okay, and then similarly, like I was telling you, that you will be exploring the PCA approach also once you start off with your the next training on the Python. So over there, you will get a little more exposure on how you use the PCA. So PCA is again, right? This is also we use largely for feature selection only. Okay, this is also the use of this also is feature selection, but this is more I will say a little complex, and uh, it can be used for numeric and categorical variables both. Yep. So with this, I think we come to the the end of the I will say the modeling techniques that we had to cover up in the R. So now I would like to just hear from you all, like the queries, questions, the things that we like to discuss over here. Yep, Sahil. So R is ended. So Rishabh, that you will be doing in your the Python training, KNN, SVM, right? Clustering techniques. Those are the things that you will be covering in your Python training, right? Like I told you starting, so everything, the model remains the same. You will also be doing the linear regression again in the Python also, and you will not find anything going change different over there. Only the coding part will change. Rest everything will be the same.
So Amit, Sahil here. Can you hear me?
Yeah, yes, I can hear you.
What I want to ask is that since now we have finished R and we have covered all the major topics related to it, so how should we exactly practice it or explore it more so that we can confidently say that I am uh, well versed with the language and I am skilled in order to be in order to sit for an interview or try to solve any problem for that matter in R.
Okay, sure. So let me do one thing. Let me just collect the questions first so that
Okay.
we answer them all one by one. Okay, so so Rishabh, so I can see lots of the questions are coming from Rishabh itself. So Raghu, random forest again, you will be doing in the Python, right? So see, basically, if I just broadly classify, right, the algorithms that we majorly use and we study are they are the linear. Okay, we have linear, logistic. We have this decision trees, and decision tree has a next part to it, that is random forest. Okay, this is just a little bit of an advanced version of this. Okay, and then you come down, you have SVM, that is support vector mechanism. Then starts the concept of your this clustering. Okay, and you have PCA. Now largely these are the the techniques that you will find. So in clustering also, do you have multiple techniques that are used, right? So one is KNN, then you have your the hierarchical clustering, right? So these are the techniques that come under this section of clustering over here. So if you see up till here, we have seen the stuff. So now LDA and PCA is advanced version of LLDA. Okay, that is what you have over here. So if you see up till now over here, we have done the things. And this SVM clustering PCA. Now these are the stuff that will be covered in your Python training. Okay, because since R was the starting of your journey point, right, of your data analytics. So over here, the basic and the base has been tried to be created for you so that you get well versed with how, because in the Python also you find the similar concept of get well versed with how, because you will find data frames, list, tuples. They're exactly like the way we have vectors and data frames and matrices in R. It is just that the names will be changed. Like we have the ggplot library in the R, you will have this matplotlib and c1 libraries for the visualizations in the Python. Okay, so just that interface will be changing, but mostly and largely the things will be similar. So that is why the other of the modeling techniques, they will be covered in your Python training over there. Okay, now when you talk of unsupervised learning, right? So unsupervised learning is the clustering technique. This is the technique that comes under unsupervised. So this is where you will, because you are covering clustering over there, so this is where you will be learning your unsupervised learning as well. Okay, coming back to the projects, right? So project as such, you will not be getting any project after the completion of the R or Python training. Okay, or for that matter any other the SQL or Tableau also, you will not get projects right after the completion of each training. You will be getting the projects in the last of your course. When all your courses will be done, then you all will be given the group projects over there, where you will form a team of 2 to 3 people, and you can choose whether you would like to work on a project on R or you would like to work on a project of Python. Okay, that is when you will be working on the projects over there, and you will also be creating the PowerPoint presentations, and you will have to give a demo. A mock interview sessions will be held for all of you. So in order to understand that how much command you all have, and feedbacks and everything will also be shared during the last course of the training section over here. Okay, so this is up till over here. Now coming back to Sahil's question, right? So Sahil, the question that you have asked for, that how you can practice more and more. See, basically there are two things that have to be kind of, you have to be strong with the R. First is the coding language. Okay. So you have to make sure that you are very well versed in terms of on how to slice and dice the data frames, matrices, select the particular variables, because that is all a part of data preparation. And this is something that you will always be doing very extensively on any other project that you will work upon. Okay. Then comes the portion of data manipulation, right? Like filtering out the data, creating new variables, creating charts on the data, right? The ggplot and all the libraries that we saw on how to visualize the data. So that is all those things, they come under the coding part. The more comfortable you are with those things, so you will get more confidence that you can easily work on that. Then the second thing that comes over here is that is the modeling concepts. Okay, so now when we talk of modeling concepts, right, so basically you should actually understand first thing that why we shall be having a why we shall be using a particular technique. So you should be clear on that, right? What are the different terminologies that are used and how do you identify something from there? Like in the linear regression, we studied about the coefficients, p-values. In the logistic regression, again, we saw the p-values and we understood a sigmoid curve, right? How that equation is converted into a logarithmic equation. What is the purpose of that? How the output is generated? So same in the decision trees. What is the use of complexity parameter? What are branches? And how do you decide the significance of the variables? Now, those are the things that come under the part of uh, the concepts that we have discussed. Okay, so those are the two things that you have to be very much strong with. So in order to walk through for any of the interviews related to the R or Python for that matter. Okay. Now the next question I think that you had was how you can, from where you can get the stuff, right? So for that, there is some material that is already there on the Google Drive. I'm not sure how much you have covered and, done your practice upon. Okay. So even if you can just complete, if you technically see, right, you any which ways have a lot of stuff with you right now also. If you will go on to your Ematicus LMS, you will find a lot of practice questions over there, right? You will find a lot of quiz also over there. That is one thing. Then you have the projects that we worked upon during the in-class sessions, right? There is material on Google Drive that I've already placed, which have the stuff related to everything, right? So I don't think that you need to go out before completing all these things thoroughly. I don't think that you need to go outside this domain any point in time. But if even after 1 month and 2 months, if you feel that you have already completed this, then maybe, right, like Raghav, if you have mentioned with the analytics, right, you can go to any of these websites. You can go to the website of Kaggle, you can go to the HackerRank, you can go to the Vidya Analytics, you can go to this analytics Vidya. There are like hundreds of websites that are available in the website which are providing that free stuff. Okay, so but what I have seen in my this, like I have been training people for more than 5 years now. What happens generally with the people is that what they feel is that what they have covered in the class, so they forget all about that stuff and they try to go out in the market and see what is the other stuff that is available. Okay, and as a result of which what happen is the people end up getting confused, right? Like over there they will see some other concept would have been used in order to explain the same thing, but we know that for doing the same thing there are multiple ways in the R or Python and in any software. So what we do is when we see that another stuff and we get confused and we lose our confidence. Okay, that I think we are not clear on the concept. So that is what one thing that happens with most of the people. Okay, this is something that happens with most of the people. So my advice would be to first of all, you all know your answer by yourself, that how much the stuff you have covered, like that we have covered in the class, right? All the assignments on the Google Drive and the Ematicus LMS and all the projects. On the projects itself, there are huge data sets. Try to think up and come up with more analysis that you can do on that. Do not just open the code and execute it. In this, we have this chart you are executing. That will not make any sense. We have already understood what we did. Now pick up the data set by yourself and start writing the codes by yourself. Do not look at the coding part or the coding file that have been shared with you. Okay, if you feel that you are now able to write each part of that code by yourself, that means you have achieved, the level where you know how to write the codes. Getting the idea what I'm trying to say? Right? So like if I share the code of decision trees with you, so it's not that if you feel like you open the code and you are executing it line by line and you are saying, okay, इस line में तो मैंने chart बनाया है, execute हो गया, चलो ये समझ में आ गया, इस line में तो मैंने missing values को हटाया, मैंने execute किया, समझ में आ गया, right? That is not the intent. The intent is you should yourself individually, you should be picking up that data set, reading the problem statement, and then writing that entire piece of code by yourself. If you think that you can do that, that is the job done. Okay.
Okay. Okay. Thank you so much, Amit.
Sure. And apart from that, what you can also do is write, like Raghu, you have mentioned a separate session for statistics. I mean, I'm not getting the point. As in, I mean, if you will try to do this, right? If you will try to think that, you will take separate sessions for statistics, trust me, it will be very boring. The reason for that is you are tech people, right? Now you have been used to using these softwares, and the whole idea of the software is to make your life easy. If you will do all the calculations by your hand and you will try, if you will feel that you will like to, see all those things, calculations happening, manually how those things are done, so it will become very, very hectic and a lengthy process, because all the statistics that you are learning in these data science courses, right? I told you in the starting of the session also that these are like complete degrees in itself, right? If you will open the module of statistics course of any of the college or universities, you will find that they learn only the statistical concepts I'm talking about. They learn all those things in 1 year. But over here, you are learning stats plus the software and the coding languages also. So definitely you will have to, somewhere you have to find the middle ground that you do not miss out on any of the things. And in the companies also, when you will go for the interviews, no one will deep dive into that advanced statistics like extremely, because that is not a data analytics role, that is a statistician role that you are thinking of. Because many people think that we need to have a very hardcore statistics knowledge, only then we can make our course in this analytics field. No, it's not that, right? Basically, it is like you should have good understanding and you should have a aptitude to understand what you can derive out from that data. Okay. But rest, I'm not saying that we cannot have the class, right? If you still feel that, would you like to have some sessions, especially dedicated to stats only, definitely, we can do that. We can keep a session. So for that, what I will do is, what I will recommend by my side is that you should spend some time in the Python first. The reason for that is because in the Python also, what will happen is you will be revisiting some of the statistical concepts. Okay. You will again be guided on what those concepts are. So in that journey, what will happen is many of your concepts will be revised and some of the new things will come on your way. So what you can do what you can do in that case is you can just collect all your concerns and doubts, and you can plan a session where we can just focus on those particular things which need attention, rather than we are spending a time here and there on the unnecessary or unrequired stuff. Yep. So now I think, so when did we start this course? Do anyone remember the date? Like when did we started with the R training? So today 3rd Jan. So 3rd October to 3rd Jan. So October, November, December. So 3 months. So we have spent 3 months on the R training. I think, yeah. So 3rd October was the batch launch. I guess on that day we didn't started with the training. It was just more like an introductory session and talking all about what data analytics is all about, and then your induction and all, how to use the LMS and everything, right? That is what the session was planned on 3rd of October, right? So officially, so we had Diwali in the middle, right? So I think we had one break of Diwali, and then 1 week I took off for my brother's wedding. So 2 weeks, I think we had kept the session off. So, but still, almost like 10 weeks, if I do not even, almost like 10 to 9 weeks we have spent. So that's a good amount of time. I mean, we have spent 3 months over here. And thanks to, most of you, like there were consistent questions and everything that used to come up. Like Rishabh, you was always very active, Raghu, right? So Sahil, in the starting, in the last few sessions, I saw your, the participation went down. So I'm not sure like what was the reason for that, because in the in the starting of the session, I could actually see that Anthu in your questions and everything. So just maintain that the momentum in the next sessions as well. Okay. So class, any feedbacks for me if you feel something that you would like to share with me? So like we have spent 3 months. So what do you feel about me, teaching style? Anything that you feel can be improvised or added or improved? Because I know one thing I'm really bad with is updating the files on the Google Drive. So I know many of times you have to remind me to get that thing done. Sure, Raghu, I'll be doing that. So in fact, I'll just do it right away only.
Yeah, but as far as my participation is concerned, I apologize for the decrease in the frequency. Actually, I had my exams, so because of which I couldn't actively participate as I was doing initially. But not to worry, I'll be, keeping up the enthusiasm as you said, and in the future classes.
Definitely, sir. Definitely wish you good luck, and everyone as well for all the further trainings as well.
Thank you,
So
thank
no,
you so
Rishabh.
much.
So the upcoming session. So I will not be taking the Python. So Python will be taken by some another faculty. So yes, you have just completed the, I will say 1/4 of your journey, right? So you will be doing four. You have 4 modules: R, Python, SQL, and Tableau. Okay. So I will not say 1/4. It is rather more than 1/4. Because I can almost say like it's like 1/3, right? Is done, and 1/3 will be your Python, and then remaining 1/3 will be SQL plus your Tableau. Because in SQL you will say that okay, I mean these things we have learned in R also, and we have seen these things Python also. So these are not new things for us. Definitely, Rishabh, you can connect any point in time. So, in fact, I'm also added into that group also recently. A couple 2-3 days back, I was added into that DSP or WhatsApp group as well. So definitely, you can reach out to me. You can just ping me over there, and definitely I'll. So sometimes it gets delayed for me, because of this, training sessions that are going around. So I'm not able to see the WhatsApp messages all the time. So if in case if it happens that I'm not able to revert to you back, please do not mind it. It's not intentional. It is just by mistake that it would have happened that I would be in the training and the WhatsApp got missed. So other chats came in and I didn't got a chance to look at it. So you can just poke me once again. I will be very thankful to you if you do that. And because it always it gets skipped due to this the training sessions. Yep. So the number is 010.
I drop a message on
Oh,
WhatsApp,
sorry.
but you
No,
didn't
sorry. I have.
reply me.
I will.
I got your point.
So you drop me a message.
Yeah,
Because
in
many of the
previous.
numbers are not saved also with me. So what it happens is that like there are a lot of students who keep on I mean they ask they keep connecting with me regarding their queries. So sometimes many times it gets missed because of that stuff. The trainings are going around. So at that point in time, I do not take a look at the phones and all.
Okay.
So that is why the things. So you can just you can call me, right? If in case you feel that you haven't received the reply, just call me back, and definitely or maybe you can just send a message that Amit, please reply to this message, so I get an idea. Okay, the guy is really angry now. I need to reply back. Okay.
Okay. Okay. Okay. Thank you.
So I've shared my coordinates, phone number, and the email ID. Okay, class. So what you can do is you can definitely take a time, right? If you need a week or 2 weeks of time, you can collect your doubts, right? Anything that is related to the art, right? And you can always let the Damini ma'am know, or you can ping on the group that when you would like to have a session, and definitely we can plan a art doubt session anytime you feel comfortable. Okay. So that is not a query. And apart from that, also in the future, definitely I'm, anytime reachable. You can connect me with me for any of your, queries or doubts you have anytime. Okay. Sure. So with that, so I think we can sign off. So thanks everyone. Yash, Sahil, Vishal, Swati, Rishabh, Anchal, Akshay, Raghu, Prerna, Saitej, Akshay, Baldev, Pooja, everyone. Right. It was really nice interacting and sharing the knowledge with all of you. Right. So I wish you all a very good luck, and definitely we might connect in some of the other sessions as well, because definitely not in Python. Maybe we might get a chance to connect in SQL or Tableau sessions that we might have, or maybe in the mock interview sessions that you might have in the future, right? So because still it's a long way to go. Thanks everyone. Thank you. Take care. Bye bye. Thanks, Jyoti. And I will upload this file also. I'm just uploading that file, the LD one that we have used.